Based on the research work that has been carried out by astronomers, the Martian moons have a common ancestor. Mars has two moons, Phobos and Deimos. They have puzzled researchers since their discovery in 1877. They are very small moons. The diameter of Phobos is 22 kilometers, which is 160 times smaller than that of our moon Luna. Deimos is even smaller, with a diameter of only 12 kilometers. Our moon is essentially spherical, while the moons of Mars are very irregularly shaped. These two moons appear to be shaped like potatoes. They look more like asteroids than natural moons. The shape of these two moons have led persons to suspect that they might in fact be asteroids that were captured in Mars's gravity field. But that's where the problem started. Captured objects would be expected to follow an eccentric orbit around the planet, and that orbit would be at a random inclination. In contrast to this hypothesis, the orbits of the Martian moons are almost circular and move in the equatorial plane of Mars. So what is the explanation for the current orbits of both Phobos and Deimos? To solve this dynamic problem, the researchers relied on the use of computer simulations. Based on the work that was done by the astronomers, the idea was to trace the orbits of Phobos and Deimos and their changes back to the past. As the research would turn out, the orbits of both Phobos and Deimos appeared to have crossed in the past. This indicates that the moons were very likely in the same place and therefore have the same origin. The conclusions coming from the researchers was that a larger celestial body was orbiting Mars at that time. This original moon was probably hit by another body and disintegrated as a result. Both Phobos and Deimos are the remainders of this lost moon. And it is not difficult to follow these conclusions. They required extensive preliminary work by the researchers. First, they had to refine the existing theory describing the interaction between the moons and Mars, because all the celestial bodies exert tidal forces on each other. These forces lead to a form of energy conversion known as dissipation, the scale of which depends on the body's size, their interior composition, and not least the distances between them. Mars is currently being explored by NASA's InSight mission, with ETH Zurich's involvement. The electronics for the mission seismometer, which is recording Mars quakes and possibly meteorite impacts, were built at ETH. These recordings will allow researchers to look inside the red planet, and the data will be used to constrain the Mars model in their calculations and the dissipation occurring inside the red planet. Images and measurements by other Mars probes have suggested that Phobos and Deimos are made of very porous material. At less than 2 grams per cubic centimeter, their density is much lower than the average density of Earth, which is 5.5 grams per cubic centimeter. There are a lot of cavities inside Phobos, which might contain water ice, and that's where the tides are causing a lot of energy to dissipate. Using these findings and their refined theory on the tidal effects, the researchers ran hundreds of computer simulations to track the orbits of the moons backward in time until they reached the intersection, which is the moment when Phobos and Deimos were born. Depending on the simulation, this point in time lies between 1 and 2.7 billion years in the past. The exact time depends on the physical properties of both Phobos and Deimos. That is how porous they are. A Japanese probe scheduled for launch in 2025 will explore Phobos and return samples to Earth. The researchers expect that these samples will provide the needed details about the interior of the Martian moons and will enable more precise calculations of their origin. Based on the research work that was done by the astronomers, their calculations indicate that the common ancestor of Phobos and Deimos was further away from Mars than Phobos is today, while the smaller Deimos has remained in the vicinity of where it came into being. Tidal forces are causing the larger Phobos to approach Mars, and this process is ongoing. Based on the researchers' explanation, their computer simulations also indicate the future development of the moon's orbit. It seems Deimos will move away from Mars very slowly, just as our moon is slowly receding from Earth. Phobos, however, will crash into Mars in less than 40 million years or be torn apart by the gravitational forces as it nears the planet Mars. Orbit of the Martian moons hints at an ancient ring of Mars. Scientists from the SETI Institute and Purdue University have found that the only way to produce Deimos' unusually tilted orbit is for Mars to have had a ring billions of years ago. While some of the more massive planets in our solar system have giant rings and numerous big moons, Mars only has two small, misshapen or irregular moons, called Phobos and Deimos. Although these moons are small, their peculiar orbits hide important secrets about their past. For a very long time, scientists believed that Mars' two moons were captured asteroids. However, since their orbits are almost in the same plane as Mars' equator, that the moons must have been formed at the same time as Mars, but the orbit of the smaller, more distant moon Deimos is tilted by 2 degrees. The fact that Deimos' orbit is not exactly in plane with Mars' equator was considered unimportant, and no one cared to try to explain it. A research scientist, however, said that once they had a new idea, they looked at it and new eyes revealed new secrets about the orbital tilt of Deimos. This significant new idea was put forward by someone from the Purdue University and a graduate student. They managed to state that Mars' inner moon Phobos is losing height as its tiny gravity is interacting with the looming Martian globe. Soon, in astronomical terms, Phobos' orbit will drop too low and Mars' gravity will pull it apart to make a ring around the planet. Generations of Martian moons were destroyed into rings. Each time, the ring would then give rise to a new smaller moon to repeat the cycle over again. This cyclic Martian moon theory has one crucial element that makes Deimos tilt possible. A newborn moon would move away from the ring, and Mars, which is in the opposite direction from the inward spiral Phobos, is experienced due to gravitational interactions with Mars. An outward migrating moon just outside the rings can encounter a so-called orbital resonance, in which Deimos' orbital period is 3 times that of the other moon. Like, comment, share, and subscribe. Let me know what you think about these new discoveries and research work that is being done in relation to Mars and its 2 moons, Phobos and Deimos. Thanks for watching and goodbye.